Focus just 10 minutes on the aspects, the critical aspects of feed manufacturing. And so we have approximately, as I say, 9 or 10 speakers covering these subjects. So we start with storage, we go through weighing, dosing, grinding, mixing, we end up pellet systems, extrusion, grain cooling, coating and pelleting, palleting, and then finally automation. So, without further ado, let's get started. And our first speaker is VIV MEA. I'm sorry if I've mispronounced it, Delamere. And he's from SCE in Europe. And he has 20 years experience in global feed and food industry. He joined I'm dyslexic. He joined SCE 7 years ago and is responsible for the African and Middle East region. He focuses mostly on exploring opportunities with major industry players and offering solutions to optimize their process buildings. So, Vim, you're discussing storage. Welcome, and the floor is yours.
Roger, thanks for the introduction. Thanks for organizing the Build My Feedmill. It's always a pleasure to be able to present, and I really like the concept where you follow the process. So basically today I will be speaking about process storage buildings specifically for feed, and then how can we optimize your return on investment by designing and building a good process building based on square silos. First of all, feed milling is all about conversion rates, so it's all about doing more with less. It's all about efficiency, all about, using as little as possible resources, being raw materials, cereals, energy, footprints, and turning them in as much as possible good feed to have good animal proteins. So, and your building actually is a building which will support you in that. First of all, SCE, we're a Belgian-based company with factories in Belgium, Germany, and Vietnam. We're family-owned, and we do projects worldwide. We worked in 82 countries now. Mainly, let's say, historically was mainly feed, but in the last 30 years, let's say more and more it's also flour, rice milling, process storage in other industries. Summary of today's presentation. So we will start from your process maps, same as the full conference. Then we say, okay, how can your building, how can we design that intelligently? Then we go through each of the bins and what is specific for each of the bins in a process building for a feed mill. We look at hygiene, and then, okay, we have maybe still a little bit left for 1 or 2 questions. I don't know whether it's with Q&A or not. Let's see. So we start from your process maps. Basically, on the left side, you have storage. I won't discuss storage. I will discuss everything which is to the right. Basically, from dosing, we go to your factory, which is a vertical process. Then we go to finished products. So, feed mill design, feed mill by SCE is based on square silos. Why is this? It's to optimize actually capacity on a certain footprint. This is important for your energy usage, because the more you do on either limited footprint or limited height, actually the more you save on conveying or lifting your product. So on the left side you would have dosing bins, we'll discuss that. Then you would have in the middle, you would have the meal bins above pallet press, and then you would have your finished products, which is here a little bit specific to be able to load very fast. This is the same project. You see that actually the space taken up by the storage in a building is actually up to 60-70% of your process building. So if this 60-70%, you would do this in round bins, actually your building would end up much bigger, up to, let's say, building volume 25% bigger than with square silos. So what we do is actually, okay, we pre-engineer. So this is a a purpose-built building, so it follows the process. First of all, the process, which is by the machine supplier, defines this building. What is the capacities for dosing? What is the number of floors? What is the machines which are required? How will you treat your and store your finished product? Based on that, we make a building indication drawing. Based on that, we will make, let's say, everything in the factory, as much as possible in the factory, because what you do in the factory is better quality than what is done on a job site. So we work with prefabricated elements. Everything is shipped in containers, and then on the job site it's just assembly. Your building, you see that actually the silos, they are a structural part of the building. So the silos, they are supporting your process. They are taking the loads from the machinery, so static loads, dynamic loads. They're also taking the loads from seismic. They're also taking the loads from the wind. This leads to a lower cost of ownership. Why? Because first of all, okay, you have to take into account the vibrations. These are buildings which are built to last up to 50 years. Next to that, you will have to take into account this is easy to maintain. Housekeeping should be easy. Should try to make your building as simple as possible to avoid any dead spaces, so it's easy to clean, and you can operate your feed mill with as few personnel as possible. So here you see in practice how you build. You see you start with the steel structure. Then on top of that steel structure, you put your bins. The bins, they come in panels. Panels are 1 meter high. This is to be containerized. In the middle, you see that your process building is actually supported by the bins. So the bins, they are a structural part of the building. And then actually means that we can do a lot of things in parallel. So we are constructing on site while we are manufacturing in the factory. So we can reduce the time to build and to be operational, which is also critical for, let's say, your return on investment. Because at that moment you have already invested in your machinery, so you want your plant to be operational as soon as possible. And this you can do worldwide. So the system is made to be installed worldwide. You see the bins. The bins actually, they are supporting your floors and they are supporting your roof. And all of that is prefabricated elements which are made in a factory, so in a controlled environment. I will skip this because I think time is limited a little bit. So specific for feed milling, what is important? First of all, if you store or process storage, it's important to have first in, first out. So you want to make sure that in your dosing bins and also in your finished product bins, whatever comes in first goes out first, and also that your bins are clean. This is important for cross-contamination. There's a high level of hygiene. Why? Okay, you're working with natural ingredients, so you have to make sure that you don't get any pests or rodents, and that your building is clean. And then, okay, based on what you are storing, you have a different solution. So if you are storing soybean meal, which is not so good flowing, or minerals, this is a very different solution than if you have, like, for instance, cereals, which are easy flowing. Then, if you look at this, these are process storage silos. So you fill them every day, and some of them are even filled, let's say, a few times per day. So if you have, for instance, a 60 ton per hour feed mill, the bins which are above the pallet press, actually all the product has to go through there the whole time. So your bins needs to be designed to last for 50 years to do that. And then also you have to design your mill to be flexible. Why? Because today you use a certain recipe, but you know that your raw materials, they will change over the next 50 years. So you have to make sure that, and actually the evolution is the raw materials, they get more and more difficult because more and more people are looking at, okay, waste streams of the food industry to use in feed industry, and more they are looking at things which are difficult to store and to process. So here you see, for instance, dosing bins which will be above scale. For dosing bins, we recommend to have smooth wall silos. Why? again, to have this flexibility and to have this first in, first out flow in your silo. Then if we move to these bins, this would be mineral bins or medium component bins. So you can see that, okay, actually within a building, you can have bins on different heights with different sizes. Typically, these mineral bins will be higher in the building. Then, okay, you go to these meal bins. These bins actually are filled and emptied continuously. All your product goes through there. So what is important there is that actually you can guarantee that the bin really empties, because if these bins are not functioning, actually your mill is not functioning at all. And you want to avoid cross-contamination from one batch to another. Then your finished product bins. This one is a bit specific. Either you go to bulk outloading or you go to bagging. This one is actually okay for bulk outloading, but to able to load trucks with different compartments as fast as possible. So you have storage bins, and then you have what we call contra sets. In the contra sets, we already preload, let's say, the bins for the truck that is about to arrive. Hygiene, so on top of your bin, actually your bin top has to look like a floor. So it needs to be easy to clean. If you walk on it, okay, you might be 35 meters above the ground, but it should feel like a secure floor. And everything has to be foreseen to accommodate your process. All the connections are there for conveying equipment, for filters, so to be able to be easy to clean. So we don't cut on site, we have to connect there with bolts and nuts, because whatever you cut on site or weld on site will be worse quality than what you do in a factory. Inside the bin, so the bins in a feed mill, except maybe for pallets, we make all bins smooth walls to guarantee flexibility. Because what you can store in a smooth wall bin, what you can store in a smooth wall bin, no, it's the other way around, sorry. What you can store in a corrugated bin, you can store in a smooth wall bin, but not the other way around. If you would store, for instance, smooth soybean meal in a corrugated wall bin, actually your bin will not function after a few days already. So, and then, okay, also we have to pay a lot of attention to the design of the hopper. We have a patented hopper, which is called the butterfly hopper, to ensure mass flow. And also this hopper actually also allows for flexibility, because you go first from a square bin to a round outlet, but below that round outlet actually you can adapt to your process. So also if your process changes, you just need to adapt the under hopper, and you are ready to accommodate for a new machine. Then more and more feed is going to food standards. So we also look at insulated buildings to be able to control temperature inside the building, to avoid also condensation, and also to make sure that it's easy to clean. So we usually install the sandwich panels horizontal. So from the inside, you don't have any cladding rails where you could have dust or rodents. Again, the goal is to have good housekeeping, to be able to operate your mill with as few as possible personnel. Thanks for your attention. If any questions, you can visit us at the booth or after the conference. I'm available for questions.
Moving straight on, we've got Bas Versailles, as he's from KSE, and he's going to talk to us about weighing and dosing. Bas is responsible for global sales and marketing at the company, with extensive experience in both brownfield and greenfield projects across feed, premix, aquafeed, and pet food industry. He combines technical experience and experience with strategic vision. He's passionate about innovation and long-term partnerships. He supports clients worldwide in optimizing their processes and achieving sustainable growth. Bas, floor is yours.
Thanks, Roger, and thanks for the nice words. I didn't know I made it that complicated, but yeah, like Roger said, my name is Bas. I'm globally responsible for sales and marketing within our company. Today I want to talk a bit about smart dosing, because you have a very nice storage facility of SAE, and then it comes to the point that you have to take it out of the bin. So the subject of today is smart dosing, what it adds in value to your product and to your cost, and of course to your production process. So starting with the company in general. So we are a company with 3 legs. We are Dutch, so coming from the Netherlands. We have 3 legs. So one is dosing systems. So we do a lot of batching systems. We do that globally. We have an automation leg, full factory automation from the part where you take in your product till the part that you load out your product. And then when those two come together and you look at the full process integration of multiple KSE products, we have a consulting group that can help you with designing this process and bringing it to the next level. We exist for over 50 years. I believe it's 53 this year. We do about 30 million. We have about 150 people, mostly technical. We engineer and produce everything in the Netherlands, but we supply that globally. So we have built factories or machines on each continent. 95% of what we do is coming from pet food feed premix. The other 5% is divided in chemicals, building materials, very odd markets. So we only do what we are good at. We are a specialist on that part. For all the other parts, we like to collaborate with your partners. If we talk about the vision we use in our company, we say, okay, the factory of the future will only have 2 employees, a man and a dog. The dog to keep the man from the equipment, and the man to feed the dog. And maybe it's a common saying, but you know, everything we design, we develop, and how we think about the process of your factory has this in mind, so it has to be smart. So if you look at our product range, we talk about weighing today. So what is red in this picture is what we supply. So it starts from product intake, macro dosing, like Wim already told you, to mineral medium dosing, and a big part is of course micro dosing today with the increasing number of ingredients and difficulties. Then we go to production, we do some batch transport, and then on the right side, already like Wim showed you, you have the truck filling, either with the contraset or directly in a truck or in a bagging line. So what is the value of dosing? So basically, it's the base for your product, because you spend a lot of time developing the good recipe for your protein production, and you want to produce exactly that what you're designed in or what you developed in nutrition. So you want to improve the quality, secure your formulation in every batch. You want to increase the production by faster dosing. We see the factories are more and more under pressure. You want to go from, I don't know, 10 ton an hour to 11 to 12. You know, it keeps on increasing because the people are, you know, number of people in the world are also. We want to save money. We all like, you know, prices are under pressure in the market, so we want to have the most efficient and least cost production process. Of course, we don't want a lost product, and we want to eliminate the risk of human mistakes. And I think that's maybe even the most important one of this whole list. I see my letters are a little off, but if we talk about the recipe, we see 95% is on the left side. It's grain, corn, soya, minerals, residential streams, oil and fat. But on the right side is where all the critical components are: additives, colorants, preservatives, vitamins, of course, trace elements, maybe medication, and that's only 5%. But that's maybe mostly the 5% that gives you a lot of headaches. It's also 65% of the number of dosings. It's 75% of the number of ingredients. It's 80% of the raw material cost, and it's 90% of the added value. That's where it happens. And we see a lot of these processes are not under control. So we want to make that good, but also smart. So to start with good, what is good dosing? Is of course accurate, fast, consistent, that it's always the same throughout the year, and predictable, because if we can predict it, we can control it. But what makes it a smart dosing? It means there is no operator action, it's self-learning, so nobody touching the equipment, and it's self-optimizing. So in that situation, we can go to the man and the dog. So if you talk about smart dosing, it starts in the middle. You need to have intelligent equipment to do that. So you have to have sensors, you have to have smart software, you have to have a lot of things to make the machine giving you the data to put in an analytics tool. So we collect all the data from your equipment, In the equipment, there is a smart software that uses that for self-optimization. And we use that same equipment in designing the next step of your factory. So what means that, so we have a database, a benchmark database of hundreds of machines all over the world. They're all connected to a database of KZ. We run those analysis and we use those values in the design of your new plant. And that's what you see on the left. So if you ask KZ, okay, can you do this? We do that based on facts, based on experience we have in the market. So a data-driven design. So like I said, right top corner, benchmark database. So all the machines are connected, we collect all the data, we put that in a database. We have equipment specifications like dosing range, accuracy, technical specifications of the machine. And then of course we ask you a lot of questions because you are the people producing feed. So you have all your recipes, you have all your information, you know what you do, and you know what you want to do. So we put that all in a tool. It's an in-house developed tool that connects these three together, and it gives you scenarios. And those scenarios are used to design your production process. And to keep it a little short today, I only took three. Of course, there are many ways of doing this, but let's say basically you have three design concepts. This is all based on premix. Of course, that can be adapted to feed or pet food. But if you look on the left, is the traditional way. It's gravity, so we build a very high tower. Actually, Wim does that, so they build a very high tower. We put in the equipment, and by gravity, so pipes, we connect it to the next process step. Of course, very clean setup, low contamination risk, low equipment cost, because normally this is the most simple or, let's say, basic equipment. Low energy, but the disadvantage is that you need a very high or tall building, and that's not always allowed. So if we want to reduce that height, we go to the second concept. What is conventional transport, in this case vacuum. So we built, on the left we built a dosing tower with all the bins, and on the right we built a mixing tower. The mixing tower, in this case only bags, but that can be also feed production. Of course the building will be a lot lower, but the equipment will be higher, there will be more contamination because you have more touch points of your product throughout the process. Maintenance will be higher because you have a lot of pressure on the systems, and it will also be high energy consumption, what we don't like. And it's not so easy to expand, because if you set this is what it is. And then we have a last concept that is the most innovative concept, what we see more and more in premix production and a little in pet food, is containerized. So the containers replace the vacuum transport in the middle design, and collect from every process step all the ingredients. So you have a 100% contamination-free process because the containers are dedicated to contamination groups, raw materials, recipes, and the software will track all that. It's fully RFID driven, so we know where what container is and what content is in the container. And then you reduce the building even more because you can go from the silo directly in a container. You build one floor with all the equipment on the ground floor that is moving, and the dosing equipment one level up. And you go to the right, to the mixing tower with using an industrial elevator, fully automatic discharge into the mixer, and from there you can easily expand this. Because if you go to a second mixer, we just extend the track, make a discharge point, and you're ready to go. Energy consumption very low, all small motors, equipment moving slowly. So low maintenance cost, of course a low building, but also the personnel you have on site will be feeding the dog in this case, because it's fully automatic. Of course the downside of this is this will be the highest cost compared to the other concepts. So we have a lot of data you receive from you. We have a lot of information about your production process, and at some point we translate that into a design. We do that before we start anything. So on the right side you see a premix plant. We make that in 3D, 2D. We make of course the load and construction value, so Wim can design the building and the bins. We go to P&ID, so we know what equipment is where, what needs to be controlled by, for example, software, and equipment specification list, and of course the cabinets. So from here you have a blueprint of your factory. You can go to every construction, local company doing construction, electricity, cabling, whatever you name it you need in a factory, with your blueprint and ask for the cost. So that's in a nutshell what we do. I'm happy to invite you at the shared booth with ASM and Frigotech to talk more. Thank you.
Okay, we're going to now move to grinding, and we're fortunate to have Joseph Barbie here from ESE and INC. He's a graduate of the Canadian University for Mechanical and Industrial Process Engineering and migrated to South America as a special process engineer, designing and installing many process systems and production plants. He came back to the US specializing in aquafeed production technologies and built the first special shrimp feed plant in China, China Sea Resources in Nanjing, and later developed, designed and built over 380 process systems and plants in over 50 countries around the globe, and initiated his own engineering and manufacturing company as early as 1983. Partner of several cultivation and production facilities of fish and shrimp in the USA and Latin America, and owns genetics cattle ranch, applying the latest production and nutritional technologies to his own species. Okay, Joseph, the floor is yours. Welcome.
I'm going to do it here because of my little handicap, which is due to COVID. That would paralyze both of my legs, but it's getting better. Anyway, we are talking about, nice to be here, by the way. We're talking about grinding. And I guess everything is important in a feed processing. And Roger did a great job here with, and his team, with presenting us with a flow diagram, a process flow diagram, which of course starts with the storage and the handling and the dosing and the weighing and dosing and so on and so forth. But the first process in our feed plant is grinding. If it's pre-grinding, post-grinding, fine grinding, whatever. So grinding is important not because just we have to grind the grain in order to have a uniform product to mix, because obviously you cannot mix dust or powder with granular products. That doesn't mix. So we need to have a uniform product, uniform ingredients to make a good mixing. I have a few pictures here of the history of grinding. And of course that goes back to hundreds and hundreds of years. And I found it very interesting the way grinding used to be, and when grinding started, and what we are doing today. I guess I'm going to start out with a grinding of today's technology in roller mills. You know, I always recommend very highly, if you do not pellet, don't use a hammer mill for grinding. If you don't pellet, use a roller mill. There's several reasons for that. Number one, it's a lot cheaper, a lot less horsepower. And number two, no fines. As a matter of fact, I spoke to a lot of people here during the last 2 days, and there's a lot of laying hens in the United Arab Emirates, in Oman, and so on. And the laying hens are a good example. You don't really pellet for laying hens, but you feed mash feed, which is much better to be ground in roller mills. Roller mills, they can come in single, in double, like this one here, or in triple set of rolls. And they will grind a very uniform, 600, 700 microns, no dust. You know, one of the biggest problems in chicken is that dust goes up the nose, and it causes a lot of health problems. And also it's a cost issue. So really, we have changed in many countries a lot of hammer mills to roller mills if we are not pelleting. If we are pelleting or extrusion, this is not an issue, this is not an option. So what does grinding involve? I mean, we have in the more modern ones, and even today, we have post-grinding. That means we are grinding everything. We are dosing, we are weighing, and we are grinding, and then mixing. In the United States, normally we don't design the feed mills that way, or in Canada. We pre-grind. The reason for that is we pre-grind only the grain most of the time. Soybean meal or fish meal very seldom because it already comes ground. So basically we only have 1 or 2 ingredients to grind, and that's why it's more economical to pre-grind and then get into the dosing bins and then dose and mix. In Europe, in my times, we couldn't afford to use corn. As a matter of fact, I've seen formulas in France, in Germany, in Great Britain, which didn't have any grain in it. I don't know if you're all young guys, but if any one of you remembers, we had, you know, when those pre-conditioners or Mandoscal came out with those pre-compactors, the reason for that is because we had to get energy into the feed. And what did we do? Very high oil fats into the formulas, but no grain. Byproducts, tapioca, yucca, imported from Thailand and so on. Poultry feed, poultry rations with absolutely no grain at all. So obviously that's the only difference really in the design of a mill, about pre-grinding only what you need to grind or grinding everything before you mix. But anyway, there's different, this is I'm jumping. This is a normal grinding system where we, for grinding, this one here in particular is pre-grinding and post-grinding. This is the typical hammer mill. Pulverizers, which are kind of disappearing in the market because pulverizing is a very expensive. We use it a lot in the pet food industry for extrusion, as well as in the shrimp and fish, also for extrusion. But it's a very expensive process, and I think we can do that without pulverizing or micro-pulverizing. The basic grinding here, as you can see, which is your hammers, your screen, your feed, or your product, your grain comes in a feeder, controlled feeding system. And what really counts on grinding is the tip speed, which means the speed on the end of the hammer going around the screen. And in fine grinding, the closer we go to the screen, the better fine grinding we can get, and the higher the tip speed is. So basically, that's your basic grinding processes. This is a design here for your air assist in the grinding, which is very important. The air assist basically helps to draw the product through the screen and to help discharge the screen. So if you go into a mill and you test the ground product, and if it's hot, you're not grinding correctly. It should be as cool as possible during the grinding process. If it's hot, it's because it's going round and round and round in the grinding chamber, and it's heating up, and that's not the way it should be. Why are we grinding? Like I said before, we are grinding because of mixing, a uniform mix. We are grinding because of conditioning. I mean, your steam conditioning, I cannot condition a product which is kernels or too big or too hot, and because of extrusion or pelleting. Obviously, like we always say in the pelleting technology, if you don't grind it before, your rolls and your dies are going to grind it. And that's the most expensive grinder you can buy. If your roll and your die are going to grind your feed or your grain, that's not good. No doubt, I must make a little point here. I was very surprised a couple months ago. We were on a big convention in, and one professor of the Auburn University has made a presentation about grinding, and he showed a picture from a Brazilian feed company, and in the pellet coming out of the die, you've seen the corn in there. That's exactly the contrary of what we always teach about pelleting. I mean, we want to have a uniform, a fine grind. Extrusion, never mind. I mean, in extrusion, that's extremely important. But he said that the chicken, and I'm not going to get into details because I know you're going to ask me a lot of questions because I did too. He said the chicken, the digestive system in a chicken really should not eat very fine ground feed. I said, Professor, if this is true, we are going to have a revolution in this world in this feed industry. Because he said, well, there's a lot of details about it, but the studies say that we should not grind as fine as we want to for the pelleting process. Anyway, this is only to show you how important grinding is in a total feed production and an extrusion or in a pelleting system. You know, your grinding here is 20%, but your conditioning is another 20%. And here you got 40%. So all this here is a reason why we are grinding. So grinding is obviously extremely important. It influences your products. People were talking about here before about the pet food industry. You know, when you see those pet foods, the different forms and shapes, and you see those holes in the pet food, that's not from the extruder. That's from grinding. It hasn't been ground uniformly and fine enough. So grinding influences in the whole process, all the way from your mixing, all the way through the, so this is a shrimp feed plant, and so this is the end of it. I think I've done the 10 minutes. You know, grinding should be really 10 hours, not 10 minutes, but I cut everything, and I didn't know how to cut more. So anyway, thank you very much, Roger. Thank you for listening.
I will be talking about pelleting today. The rest of the process has already been covered to quite some extent. Now it's all about pelleting. A little background about the company. We are a family-owned company founded in 1909. So we have been around for quite a while now. We do turnkey processing solutions in the animal feed industry, but also for aqua feed, pet food, premixes, concentrates, the whole spectrum, what you would see. We do turnkey solutions, individual processing lines, individual machines, renovation of existing feed mills, expanding existing feed mills. The whole spectrum we can supply. We do the design, we do the engineering, we do the production, everything in-house within the Netherlands. We produce everything in the Netherlands to achieve the highest quality standards, which is important for us. And afterwards, of course, there's training, supervision, installation, servicing of the machines and the installations that we are providing. We are a global company. We supply our machines worldwide. About 90% of our business is export related. We do that across the world. We have 350 employees, 500 projects worldwide, and we produce our equipment across 6 locations within the Netherlands. Now I will be talking about pelleting. What we see in our automation and control systems is that 65% of the energy consumption within a feed mill comes from the pelleting process, which is a lot. Energy is cost, and cost is something you would like to reduce as much as possible inside a feed mill. The operational cost you would like to reduce. The pelleting machine is a big energy guzzler, so we found that it was a good reason to see if we can reduce the energy consumption for the pellet mill. We started with that innovation already in the 1980s, so we're working quite long on this innovation already, and now we found the perfect solution, and that is to press with only one roller. We see multiple advantages in that, and the biggest one is the inlet angle, which you see over here in pelleting. That means that the contact surface of the mesh between the roller and the die is much longer. So the benefit that you achieve over here is that you can press more mesh immediately in one compression in the die. And that means that the pellet stroke is longer. Normally when you have when you use two rollers, the pellet stroke is quite fragmented. And when you push more mesh towards the die, the pellet stroke is longer. That means that the PDI will improve, but also that the energy consumption of the press in itself reduces. What we see in different tests that we have done, and also what we see in our automation and control system on the pellet mill, is that the energy reduction is between 20 and 30% in the complete process, which is a lot if 65% of the pelleting energy consumption is in that process. Also, it allows us to press with a low die speed, and therefore we can use matrices with a larger LD ratio, which also improves the pellet quality. Because we can use only one roller, the distance being traveled by the matrix is also shorter. We calculated with the circumference of the ring and the die. We multiplied it. The difference is with two-roller system is that you at the end you have to multiply it by 2, and there we can see that the distance traveled by the die is much more. That means also reduced wear on the system, because if there is less distance being covered, that means that the wear is reduced as well, also by around 30% is what we see in the process. So there is energy saving. I already explained a little bit about it, because there is optimum pre-compression in the lining of the die. That means energy saving. There is more feed pressed through at once. That means energy saving and an increased pelleting durability index. And there is optimal friction. There is no additional heat generated in the process. That means that more, the roller is quite high, heavy, so that means that the production in itself is more stable, and that means also optimal friction and reduced wear. This is a result that we have from one of our customers. The feed process is, in this situation, we are pelleting cattle feed. There is an expander before the pellet press, and there is a monoroll below. And what we found is that the energy saving of the monoroll in itself is 23%. And if you look at the total energy reduction in the pelleting process, it's around 20%. This is another result that we have done. This is from a customer in Germany. This is the recipe formulation. Oh, this is the recipe formulation. So we see what kind of materials are inside the formulation, and then we can approximate the reduced energy consumption for that particular machine. In this situation, the energy reduction is around 22%, and the throughput is the same. I think we're quite happy with this new innovation. We're helping lots of feed millers nowadays to reduce the costs on energy level, increase the throughput, and reduce the wear of the machine. So we are happy with that innovation. If you have any questions about the pelleting process in itself, please come to our booth. I'm happy to tell you more about the process. we can look at the material composition that you have and see how we can optimize your process. Thank you for your attention. And
Just slightly along to expanders and extruders, and we have Terence Hovels from Andritz here to talk to us about that subject. And Terence is a seasoned professional in the aqua industry, currently serving as an applications and technology engineer for Andritz Feed and Biofuels. He has a strong foundation in mechanical engineering and over a decade hands-on experience, and brings a practical, result-driven approach to feed production and process optimization. His career spans key roles where he led maintenance and improvement initiatives, and earlier as a maintenance engineer. Terry's expertise lies in streamlining operations, enhancing equipment reliability, and implementing sustainable feed technologies. Quite impressive. Thank you, Terence. Welcome.
Thank you very much, Roger. Yes. So, yes, I'm just going to talk a little bit about extruders, expanders. Obviously, the same physics, but they have different jobs. So, just a little bit about myself. I'm an application and technology engineer here at Andritz. I've been with Andritz just short of 2 years now. Prior to that, I was a maintenance improvement manager at a large pet food manufacturing company in the UK. We produced in excess of 160,000 tonnes a year of economic and premium economy pet food, where we had 4 extrusion lines. I had the pleasure of working with 4 Andritz extrusion lines, so it's fair to say that I know the equipment fairly well and how to get the best out of the equipment and how to run it. Prior to that, I was a mechanical engineer, so I learnt my trade in the motor industry, and I brought that experience over. So, a little bit about Andritz. So, Andritz, we never stand still, so we're always feeding and fueling the planet. You know, we're a global company. We've got global locations all over the world. We have service in Canada. We've got it in Mexico. We've got in LATAM. We've got it in South Africa. We've got a lot in Europe, and then India as well as Australia. So we are a very global company when it comes to service. We've got manufacturing in Slovakia. We've got manufacturing in China as well. So that's just a brief introduction of where we are placed in the world at the moment. So, expertise and competencies. So, what we can do. So, 186 years experience in single equipment. We've got process and application knowledge. We've got the engineering knowledge. We've got the project management knowledge, as well as the automation and service. So, we can deliver anything from single equipment to full-blown turnkey solutions. We can provide complete plant solutions for feed, pet food and biomass industries to your exact specification at the lowest possible total cost of ownership by leveraging our extensive process expertise and experience. And with the industry's most trusted services, we are always there for you. So if you can dream it, we'll stand it up and we'll stand by it. So, expanders, extruders. So, extruders and expanders, same physics, different jobs. So they've got shared process principles. So extruders and expanders both use heat, pressure, shear and moisture to process feed and pet food materials effectively. Expander functions. Expanders improve pelleting by enhancing durability, hygiene and throughput as preconditioners in the production lines. Whereas an extruders function, extruders cook, shape, texturise final products like kibble, aqua feed, pellets, integrating cooking and forming steps. So strategic technology selection, so similar technology but different purposes, and one cannot replace the other. So if we just look on the left-hand side, so at the top you can see a very basic outline of an expander, where we put steam into the expander. We've got temperature and how temperature and pressure is used, whereas in the bottom where we look at the water addition, the steam addition into the extruder. So where an extruder has a lot more benefits, yes, the initial out cost is significantly higher, but you've got a lot more flexibility with an extruder. You can screw configuration, retention times, end product size, shape, whereas an expander is part of the process to the pellet press. So, common principles and control parameters. Extruders and expanders use preconditioning, compression, shear, flash expansion to modify feed structure effectively. You know, there's key parameters include moisture addition, temperature management, pressure, specific mechanical energy to control the process. But you've got different end goals where expanders prepare material for pelleting, enhance food safety and performance, extruders finalise, cook and shape. So just a little bit on that. So an expander is part of the process where it serves a certain purpose. An extruder actually takes it to its end goal. So with an extruder, you've got the ability for oil addition, water, steam, where you can really put a lot more mechanical energy with a little bit of thermal. You are very limited with the expander to the amount of mechanical energy because the retention time of being in a expander. So roles and benefits. So increase capacity and optimise the process for pelleting. So expanders are installed above the pellet mills to increase capacity, improve pellet quality using pressure and steam control, temperature control, sorry. Improve product quality. They achieve high temperature, short time. Treatment, reducing bacterial contamination, preserving enzymes, resulting in higher pellet durability and feed hygiene. Operational flexibility, where expanders can bypass pellet mills to reduce expander, a granular product suitable for diverse feeding systems. So you don't always have to pass through the pellet press when using the expander, depending on the end product, of course. Expanders offer low capital investment and strong return of investment by solving pellet bottlenecks. So as we can see on the left, how we've got part of the process. So we've got the scaling system, we've got the conditioner, which the conditioner in both processes is crucial. We need to hydrate the mill. Then this is where we start to activate the starch, start the cooking process, and then we go into the feed expander. This is where we can put a little bit of mechanical in, put some more steam in, and this just gives a little bit more flexibility where we can add a little bit of oil as well, get a better mix. Pass through a crumbler, and then obviously we can go into the pellet mill or bypass the pellet mill straight into the cooler. So role and benefits in an extruder. Obviously, extruders cook, shape and texturise feed. We're integrating cooking and forming in a single machine for precise product. Extruders allow production of diverse high-value SKUs like specialist pet food, kibbles, shapes, water-stable aqua pellets. So what we can really do in the extrusion process, we can really fine-tune the conditioning process where we can get the correct retention. We can get the correct additives in there, so whether it be steam, water, oil, to a certain degree oil, and fat levels before we can impact the mechanical energy we put into the extruder, because if we put too much fat in there, it acts as a lubricant, you don't get the mechanical energy. But when we look at innovations and improving efficiency, you know, constantly evolving technologies like the Andrix FlexTex or the ECS system. So the ECS system is something that we can use in the aquafeed industry, where we can actually control the boiling point of the extruder coming out of the die. So we can pressurise the hood, we can reduce the boiling point, or we can increase the boiling point, and we can really govern the expansion rate there. Whereas the FlexTex, we have a system where we can increase or decrease the SME, and what this allows us to do is really optimise if we're using a really low starch level recipe, 7-8%. And what we can do is we can open and close using a hydraulic device. The Venturi size, this is where we put a lot more mechanical energy in, really activate the low starch in the recipe and get the correct expansion levels. So just a couple of take-home messages. So shared principles, both extruders and expanders use heat, pressure, shear and moisture to process feed, but serve distinctive purposes. Expanders, they're installed above pellet mills to increase capacity, improve pellet quality using pressure and temperature control. Extruders, we integrate cooking and forming, producing high-diverse, high-value products like specialised pet food, kibble and aquafeed. Strategic selection. While both technologies share the same physical principles, they fulfill different roles. One cannot replace the other. The right choice depends on your production goals. And if there's any questions, you know, please feel free to come and visit me on BIV 08K090. I'm happy to discuss.
Perfect. Thanks a lot, Roger. Good morning, ladies and gentlemen. Yeah, my name is Simon Kolb. I'm coming from the company Frigotech. We are a family-owned company based in the south of Germany, and we are doing the grain cooling business now since more than 60 years. We have customers worldwide, so our products are in more than 100 countries in the world. And still, there are some questions of people, yeah, what is grain cooling? Why are we doing the grain cooling? First, I would like to talk a little bit in general about, yeah, what is grain cooling, to get you a short introduction about it. Usually, I guess everyone knows silos or warehouses where people are using ventilators to bring in ambient air through the grain in the silo to cool it down, to make something against mold investigation, or make something against insect pests. And by cooling the grain, you remove the ventilator and you place a cooling unit next to the silo or to the warehouse. A cooling unit has an internal ventilator for sure, and so the unit sucks in the ambient air. The air goes through the unit, gets very cold, gets dry, and then we blow in the air through the silo. What happens is that the grain in the silo is taking the coldness from the air, so the grain gets cold time by time when the unit is running. The unit does not have to run during the complete storage. The unit is running directly after the harvest, or here in the countries when you collect the grain into the silo. Depending on the size of the unit, depending on the quantity in the silo, couple of days, maybe 1 or 2 weeks, then the grain is cold. Most question is, how long will it remain cold? Because outside here, especially in UAE, the temperature can go up to 40 degrees, even more. So that is a very nice benefit of the grain itself, let's say, because the kernels of the grain are round, not depending what type of grain it is, also soybean, sunflower, whatever. So the contact points of the grain to the next grain are very short, and there is not a lot of contact points between the kernels. So there is a lot of air in the silo, and the air is a very, very nice insulation. So the grain will remain cold for several months, even in these countries here. For sure, it is much more nice when the silo is insulated, for example, itself. But nevertheless, you start the cooler, you cool the grain down, and it will remain cold for a long time. So it means you can take one cooler for more than one silo. Yeah, you can take the cooler and bring it to the next silo, and so on. Yeah, what type of grain you should cool is very easy to be answered. You should more or less cool every grain you have. It's not depending if it's wheat, barley, corn, or whatever. All grain should be cooled because all grain has more or less the same issues which is facing the grain in the storage, in the silos. And about this, we will talk now. Why grain cooling is necessary way to cool the grain. Yeah, more or less, and this number comes from the Food and Agricultural Organization of the United Nations, more than 20% of the annual grain harvest is lost. And this is approximately 85 million tons. So this is really a huge amount. And most losses are coming from insects, more than 80%. 10% are coming due to mold and fungi, and 10% to rodents and birds. And by cooling the grain during the storage, we can face directly the losses through the insects and the losses through the mold and fungi. Insects have a very nice behavior for us for the cooling, because insects, the best development point is above 20 degrees and more or less under 35 degrees. So in this area, the insects can develop in the best way. That's the reason why we cool down the grain in these countries here under under 20 degrees Celsius. Because then the insects, they will not develop, Means the insects will not eat the grain, the insects will not make a population spread, the insects will not be killed. This is always the first question what comes. The insects are not dead, the insects are in kind of a paralyze, in kind of a winter sleep. So they are still there, but when they get the feeling that something is turning, they get it, that it's getting colder and colder in the silo, so they try to run away, and they make no population, and they do not eat it. So after the storage, you have much more quantity. Here we have a very nice picture. This is coming from the Oklahoma University in the United States. You can think about that these glasses, these glasses represent a silo. And in the first glass, in the start, they added 100 grain border, lesser grain border in the glass. Left it for 7 days and then took all the adult insects out. And they stored it until 30 degrees Celsius. During the time, you can here see 1 month, 2 months, etc. The grain turned more and more into flour. And this happened because the egg spread, what the adult insects made in the first 7 days, the eggs developed to adult insects, and the insects are eating the grain. And this is what happens in the silo when there is no cooling or nothing against the insect infestation. So it means cool the grain, no insects are inside. If it's above 20 degrees and not cold, insects will come, especially in these countries here. Another thing what happens, another issue what happens, grain is a biological product. It's still alive even after the harvest. So it means when the grain is stored, there is a reaction between the oxygen in the atmosphere and the carbohydrates. This means during the storage, out of the grain there comes water and heat and CO2 out of it. This means you will have losses of the dry matter. Dry matter losses is less weight, and the temperature will increase. When the temperature is increasing and water comes out, it might happen that mold and fungi will develop. Mold and fungi is very bad. You can see the orange bubble more or less. This is the storage mold. But at 30 degrees Celsius and approximately 14% moisture content, mold and fungi will develop. Usually mold and fungi is not that big problem, but the big problem of mold and fungi are the mycotoxins. Mycotoxin comes out of the mold and fungi, this is the resulting product out of it. And mycotoxin is very bad for the health. This can lead to cancer. And there is a certain value which is not allowed to be over. And by cooling, this mold and fungi will not happen, so there will not be mycotoxins in the grain. Another thing is what happens when the grain gets water out of it, that there is the risk of clumping. I'm pretty sure you have seen this time by time that there are clumps like of concrete or rocks in the silo because of the water. And this is very bad when you would like to take out the grain of the silo, because then the grain comes not out that smoothly. And also when the weight in the silo of the grain is just on one side, some steel silos can happen to fall down. So also here we can say by cooled grain, mold and fungi will not happen, and also no risk of clumping will happen. So to sum up, we can say cooling, there will be no insect development, no mold and fungi development. Out of the mold and fungi, there will not come the mycotoxins out of it. You don't need a chemical treatment against the insects, because by cooling you have already a treatment against insects. No dry matter losses. When you store, for example, rice, the rice has a reaction to the oxygen, and white rice will turn to yellow. By cooling, this will not happen. You don't need a grain turning. Some people are doing from this grain from silo to silo to make something against insects, but then you need manpower, you need an empty silo, electricity, etc. This is not needed anymore. And oilseed such as rapeseed, sunflower, soybean, these products will not get rested. So this will all be lowered, means quantity and the quality in the silo will get up. From my side, that's all what I wanted to explain in a very short way to you. Thanks for your attention. I am together in the booth with our partners ASM and KSE, and we are in booth 8K095, and we are happy to answer all the questions you have left. Thanks a lot.
So, quick introduction of PLP, as Roger was saying. PLP system was founded in the early 80s, late 70s, and is a company dedicated to produce equipment for handling the additives in different sectors. So we work in the feed industry, pet food, food application, chemical, building materials, and so on. Company is based in Piacenza, so it's a city north of Italy. And the technology we apply for the additives are related for liquid dosing and mixing and spraying, microdosing of powder ingredients, and of course coating applications. Today we will be talking about the continuous coating application and mainly related for the poultry feed sector. So what is post-pellet coating? Post-pellet coating is commonly used in poultry feed, ruminant as well, not that common, but you can find it in a ruminant feed as well. Aqua feed, obviously we are working also a lot in post-pelleting coating for pet food. What is post-pellet coating? Normally called PPLA system, so post-pellet liquid application. It's a technology to apply additives at the end of the production line. So after pelleting, after cooling, just before your storage of the product in the silos. Typically, when we are looking into the poultry sector, we can find the additives that are added, the ingredients that are added on the coating are fats, oils, molasses in ruminants, enzymes, vitamins, probiotics, and in some cases, some type of medicines. Typical quantity for oils inclusion range between 0.5 and 3%. Some formulation we can even go up to 8% on some specific cases. Microingredients, probiotics, and enzymes are normally start in the range from 30 grams per ton, so very, very small quantities to be added. And it's used for improving the feed quality. So the first topic is increasing the oil inclusion level. Oils are used for giving energy to the feed. You cannot over add the oils in the batch mixer because it would affect the quality of the pellet itself. And so it will prevent from softened and mealy pellets if you add the oils in the mixer. It maintains a superior pellet physical quality, so better PDI of your pellets, and it creates a more stable and durable pellets with physical properties, reducing dust and feed waste. Another topic of the coating is increasing the palatability. So you can add some flavors, some aromas. It reduces off flavor from avoiding oxidation, and better characteristic of the pellets that are more appetizing. The other topic is the preservation and extend shelf life. So you can reduce the oxidation and the rancid of the oil that you are coating, protects against moisture of the pellets itself. You can add some antioxidant on the external, and you can also maintain your nutritional value and feed quality during the storage. Also important with the newest technology, so the oil is very common addition, but newest technology is to add sensitive ingredients, enzyme, vitamins, probiotics, not only that, but also other products, medicines, for example. Consider that these products are very, they can degrade with the heat that is generally created during pelletizing. So by applying this product at the end of the production line, you can have a preservation of the bioactivity and the efficiency of the vitamins, maximum nutrition value that are delivered to the animals, and also it's a better way to apply precisely the products on the pellet instead of adding it into the batch mixer. Another important point is that you have to consider that this technology is applied at the end of the process line, so you can reduce the contamination, so what is called the cross-contamination. So you can, for sure, minimize the residual oil contents if you apply it at the end, so it doesn't follow all the process line. And important, some of medicine or antibiotics can be added directly on the pellets, on the finished production. So keeping a neutral and clean process line. Typically, you would find batch coaters that they are more, let's say, easy to implement, good for when you are adding high quantities of oils, but cannot ensure a good homogeneity when you are adding microingredients. Best technology is a continuous application for increasing the homogeneity. Obviously, this technology should be done accordingly to some specific matters, so dosing gravimetrically, avoiding volumetric systems, and so on. PLP technology is what we call the empty machine. It's a twin shaft continuous coater, very gentle but very powerful on mixing. We can add very small quantities of ingredients, up to 15% of oil inclusion, especially in pet food and aquafeed. We can have different additional stage, very easy to open and clean, maintain, and so on. The dosing before entering the coating application can be done with 3 different technology, the belt feeder, gravimetric screw feeder, or a plate. Each have pros and cons, and we would be suggesting what is better for your application. The empty machine comes with different size, different models, in order to cover all the production capacity, rather as it's extruded or pelleted feed. So if we cut the section of the coater machine, we would see the 2 rotating paddles, shafts, where we are creating a fluidized bed of the product that is advances. So it comes in from one point and comes out from the other side. And with special motorized sprayers, we apply in a very homogeneous way the liquids. You can see some pictures. This is the inside of the machine, very clean, easy to maintain, very easy to clean, and so on, to change from one formulation to the other. You can see a picture here of the installation. We have a buffer hopper, the weighing belt, the coater machine with the top covers, and in this case we are applying oils and 2 different powders on the pellets. So what is the key changing of our technology? So we know that when it's a continuous application, the important thing is retention time. And we achieve this in a very good way by adjusting the angles of the paddles internally to the machine. Each paddle can be changed. Adjusting the speed of the rotating of the shaft, there are 2 independent motors. One motor is turning at one speed, one motor turning at a different speed in order to maximize the mixing effect. We have some internal dams fitted in a strategic position in the coater. But what was the main game changer for increasing the retention time is what we call the automatic retention hatch. Device fitted inside of the machine used to push back the product and keep the product inside of the machine as long as possible. Drawing of a typical layout. You can see the buffer hoppers, the weighing system, the coater machine with the motorized sprayers fitted on the top, liquid dosing application that can be designed depending on what is your requirement. We can have dosing and mixing tanks coming directly from IBC tanks and so on. The technology we are using for spraying the liquids is the SMOG, the smog system, is a motorized sprayer. This sprayer doesn't work by pressure, doesn't require any back pressure to nebulize the liquid. It's working by centrifugal forces. So we have an injection nozzle of 9 millimeter. So we have never problems of the nozzle getting blocked. Or we can even spray powder solution dispersed in liquids, and can change the capacity of the application of the liquids. As I said before, we can also add powders. When we are adding powders on the pellets, we are calling it this PSPA, so instead of PPLA system, post-stress powder application. We do this with different technologies, but all related to loss-in-way system feeders, where we can also, depending on the characteristic of the powder, add some electrostatic forces to the powder in order to have a better dispersion and a better homogeneity into the final product. We've seen before the MT coater machine, that is our most flexible system. We have also other technologies for coating. For example, this coater, we call it mass spin coater, MSC, integrates a Coriolis weigher and a spraying chamber on the bottom. So it's a very compact solution, very precise. Normally, typically used only for micro inclusion, vitamins, enzymes, and aromas. With a very good CV, when we are talking about enzymes, so 30, 50, 100 grams per ton, we can reach a value of lower than 10%. So it's a very accurate system. Thank you. I don't have PLP don't have a booth, unfortunately, this year in this show, but here are my details. You can contact me whenever. Thanks.
Still good morning or good afternoon. So last but not least, bear with me, easy, fast, and do you have the control? Yeah, thank you. So ASM is a local company. Precisely, we are from Saudi Arabia, and then we have in the last 10 years moving in the Gulf. So we have an offices in UAE, in Muscat, and 3 offices in Saudi. My expertise, let's say, it comes from automation. I used to work in Okrim, so this is how it comes from. So I opened my own company, ASM, and we are specialized in the automation business. Now, automation is sometimes can be black box, sometimes can be fishy. So my message in this, let's say, presentation, that automation has to be simple, open, and you go to digitalization, and then from digitalization to ERP and AI. So that's the message I want to deliver in this. So, simple question, I always tell to my kids, what comes first? This or that? So, yeah, the chicken or the egg. Just the way to say it and see it in a simple words. Basically, at this stage, no one cares. As long as we have a nice process, moving, no downtime, we're all happy. So that's the idea. So the mill must run, maximum output with less energy, as my previous colleagues were explaining, and then the phenomenal minimum downtime. So with this, you have to achieve the automation. Now, automation is based on standards. It does not say that if I go with this, I am not allowed to go with that. It does not exist anymore, this. So when you are doing automation, the number one, you are open to communication everywhere. So this is really something I want to emphasize on. Why? Because automation has to be the basic concept is something not anymore an luxury. It's not an extra feature. It's basic. If you look at your cars, all cars now with remote control, and you have a button in the car. So it's not anymore you have a car key. You have, as a backup in case your battery, the car key. So the automation is with the remote now. So it's something as a basic, and this is what you need to achieve. So it's just to show you your basic needs in it. So it's not a luxury, it's a basic, it's a must. So please don't do something without adding automation, especially now. This is really something you think you want to save money. No, you are creating more problems. You're not saving money. So how the automation choice? We all know this symbol and we all know this symbol. So we have Android, we have Apple, these are very famous, but do we have something in common now? Anybody knows? So nowadays, the common is the same charging plug. We are having a C plug that can work in both phones, where before, if you have one of them, you are not allowed to charge in none of them. And this is the message. So now you have the same charging for both. So which means the same concept. You use different vendors, it's fine, but you are getting the same features in both ways. And it is really, I take it as something in myself. If a vendor told me you are not allowed only to use that brand, this is for me something doesn't work. So I take it out. And this is something you need to think about. Nobody can tell you go that direction and you stay in that direction. You always have the left turn or the right turn, wherever you want to go. So that's the same. So choosing automation is based on the standards, not something done by a custom made. We have to follow the standards. And this is really a message, one I would like to deliver. So the technology, if you are not using the automation up to date, means you are using, let's say, the old ones, which I message you, give you a symbol of Nokia. Using old technology in now means you are achieving it, but you need more time, you need more people, and you get it in a very slower results. So you need always to have up to date. They get sometimes, clients told me, why I need to always upgrade my computer. It's the same thing. How many years do you stay with the same mobile? It's the same thing, but it's just the mentality is different. So you have to have it always updated to achieve better results in a less time and less people as well. Now we move to this concept of SCADA, or how to make it. The second message is to make it easy. So making it easy, when you're doing automation, it has to be understood. So if a child 9 years old can run the plant, this is called genius. We should not be doctors to run anything. We should be simple, basic message to run anything. That has to be. The other day, I wanted to book in a prestigious restaurant. Okay, this is true story. So I would like to book. They told me, okay, we have to send you an email to pay in advance in case you don't show. So I said, can you send me on message and I can pay? He said, we don't have it in the system because I don't have the email. So the laundry now can send you a link to pay online, and not a prestigious 5-star restaurant. So you are making an automation, but you are complicating it. So that's the thing. You really need to make automation to make it simple, not to complicate life, and then we have to follow the unpractical procedures. So it's the same thing here. You make graphics easy for multilingual, easy to deliver, easy to understand, and then that's called, for me, genius operations. We have developed something called after the automation, nowadays it's something called digitalizations, where you need to show in dashboards. So I just want to show you about our product, or Hercules, Basically, it's a Saudi tech. Saudi tech means you have something called Made in Saudi, and you have Saudi tech. So it's the same platform, but it is based on digitalization, where it's also approved in Siemens. So it's under Siemens Accelerator. It's the only product from the Middle East that it's sold in Siemens website. So it's something to be proud of, and it's based on digitalization. So it's not anymore only automation you stop. Now you want to connect the data and show it in a dashboard format. So a dashboard, what does it mean? You connect your bank account, you see your coloring. Red, no more money. Your green, in good condition. Your loans, your debit, is the same. That's your dashboard. So here we have the same dashboards per department. You have the sales department, you have the accounting, production, so it's the same thing. Now, when you do the dashboards, you move to something called, I want to connect it to my ERP. Because nowadays, just running the plant and being isolating from the others, you have a problem. And once you are into this Excel sheets moving around the departments, you are back to the 80s. So you really need to think it in a way how you connect live data into this. So with help of Hercules, we have a common problem between ERP team, or I would call them IT team, and SCADA team or operation, I would call them the OT team, operation team. So the issue is who does what. So let's say the common practice is the ERP team sends the planning and the SCADA does the control. Because based on their materials, priorities of what they have, then you can do it in this way. To be avoiding duplications of jobs. So with the handshake principle, which we had developed, where SCADA is not touched, you just link to it to send information to ERP. ERP does the planning and send and receive. And then we have the middle person, where it's called Hercules, that can integrate and talk to each other. And this is one of the common, easy, simple ways where you can receive live data from the plant and then take it to your ERP system. One of the dashboards I would like to show you. A dashboard means you are using charts, pies, whatever. It has to be this way, where management can see color codes, where if there is issues and arrows where it's going down. So that's the concept of a dashboard. One of the things is you can use it also by departments. Sales see something, we call it KPIs, the key performance for each department. The interest of each department, each users, each managers, where it can connect. This one, I think it went the opposite, so I'm sorry for that. This is a small programming easiness, where you see the operation of the plant, and how is the graphics showing, and how the product. I think it's, I'm gonna skip it. So the idea with automation, if you have this part now, you are not anymore automated plant. I'm sorry, I'm focusing a lot on this because it's a message I would like to deliver in this small period. This is the very, very basic, which is now you need to go to do job start, destinations. You will know the equipment's been used into this, and with this you can know how long this process took me, what equipment's been used, and then what running hours and the kilowatt tons. So I have the full spectrum. Maintenance will get the running hours, energy team will get how much tons been used, and equipment's used for the department of maintenance. And then you have a complete where you take these data, you log it into dashboards, the dashboards goes to the ERP, and you have a nice understanding of what's going on. That's my LinkedIn. It will be a pleasure to connect with you. And then we have something extra in this region. We are trying to connect where ask and questions. And it's a group we created it, Gulf Feed and Flowers, where I am not only the admin, we have 4 people, and it's a neutral. Everybody can join, everybody can ask, and please feel free to join. And yeah, thank you very much.